Hello everyone, and welcome to the Clinical Quality Language 101 presentation. Bryn Rhodes from ESAC is our presenter today. We ask that you hold questions to the end of the presentation or type them into the chat box into WebEx. Bryn, I'm going to turn it over to you so that you can start the presentation. Thank you very much.
All right, so welcome. Thanks for coming. I'm really encouraged by the turnout. Excited for the opportunity to present today. So my name is Bryn Rhodes. I've been working with ESAC as part of the Clinical Quality Framework Initiative. And what we've prepared today is a brief introduction to clinical quality language, the goals for today's presentation. Should be able to answer these questions. What is it? Why did we build it? What problems are being addressed? What does it look like, and where can I go to find more information about it? So please feel free to type questions in as you go. We'll also have some dedicated time at the end for dedicated Q&A. So what problems does it solve? Well, so if we think about the problem of sharing clinical knowledge, we look at the types of specifications that are available today. We see HQMF and decision support, various ways of sharing artifacts like event condition action rules that codify what you should do in response to particular conditions that occur at point of care, or quality measures that specify how you should measure a particular outcome. There are also guidelines and order sets, lots of different specifications and proprietary formats for ways to distribute these types of information. What we're focused on in the Clinical Quality Framework Initiative is how can we enable computable representations for these knowledge artifacts, so that we can automate as much as possible the sharing and implementation of that knowledge. So the CQF initiative kind of took a look at all of these various specifications, and they're using different formats for various components, different formats for representing the patient information involved, different formats for talking about the logic. And so what we tried to do was break down the types of information and structure represented in these specifications into groups that could logically be decomposed and then referenced from different specifications, so that we could use the same underlying core representation to enable that sharing, or at least improve the ability to share. Currently, if you have logic within an HQMF and decision support rule, it's really difficult to share that logic across that boundary. So the goal is to define common representations for that logic so that you can potentially share the definition between those two domains. With respect to the logic in particular, clinical quality language is the specification that we've developed to enable representation of things like population criteria and measures and the conditions under which a decision support rule should fire. So it's focused on enabling point-to-point sharing of executable clinical knowledge. We want to be able to automatically incorporate as much as possible the meaning of that logic. But we also wanted to provide a clinically focused, author-friendly, human-readable language. So it's currently a draft standard for trial use. It's available at that link. The link is also at the end. But that's a publicly available specification. I encourage you to take a look at that. So a brief overview of how we organized that. We tried to focus on different audiences and cover all of those within the specification. What we'll focus on today is that first one, authors, clinical domain experts, and clinical artifact authors. But just know that within the specification, we've also targeted different aspects for each of these roles. so that developers, integrators, and implementers will understand what CQL is and how we can implement it in a healthcare delivery system. In particular, the specification content has an author's guide. One of the chapters is an author's guide that's basically a self-contained introduction, and a lot of the material we're going through today is taken from that context. It's intended to be something that anyone can jump in and read and go through. So there's also a developer's guide that gets a more in-depth look. Of course, it also has the formal specifications, and it also has a very useful CQL reference at the end. So that is a complete reference for all the operators and functions available. So when we talk about the problem of sharing that logic, how do we go about doing that? If we break that problem down into the different types of information represented within the reasoning of an artifact, one of those components is the logic, and then one of those is the terminology involved, so things like SNOMED codes and LOINC and RX norm. And one of those is the data model, how we actually represent the patient information involved. So when I write a condition like value is greater than 100, that expression is an expression of logic, but it shouldn't depend on the information model any more than it needs to in order to access the information involved. And so what we did with CQL was make sure that we could talk about the model and the terminology involved independently of the language itself. So with that as kind of a framework, we can use CQL to enable this sharing, and what we're doing is incorporating CQL by reference into some existing specifications. So in particular HQMF, we have a CQL-based HQMF implementation guide. This still uses QDM, Quality Data Model, as the model of data, but it replaces the logic representation with CQL. So anywhere where you have information about how to construct the criteria, that's now using CQL, but the description of what is involved, the data element themselves, those are still QDM. And we'll get into a little bit more of that. And then on the decision support side, you have the knowledge artifact specification. It's currently using VMR, a virtual medical record, another HL7 specification, as the model. But again, we're using CQL to represent the logic within the rules, order sets, and documentation templates. Okay, so a CQL library consists of basically a set of declarations. Each of these is a declaration. The first one says this is a library named CMS55. It has a version 1. It says I'm going to use QDM. That says that's the declaration that lets you know what data model you're going to be using within this library. You can identify value sets. This declaration gives that value set OID, a local name, so that when I reference inpatient, I'm actually referencing that OID. So the terminology here just lets you introduce that concept, and then you can use it later within the expression. So importantly, with code systems and value sets used in CQL, we're not defining the actual content of those code systems or the actual codes involved in any given value set. All we're doing is providing a name so that it can be used by expressions within. And that's enforced by this construct so that we don't intersperse the definition of terminology within the logic itself. So we're keeping that separation between the logic and the terminology. So parameters are named values that can be provided when the measure is evaluated. For example, the measurement period for a quality measure. In this case, we're specifying a default interval of January 1st, 2014 to January 1st, 2015, immediately before. And that's so that you can provide that as a parameter during execution so that you don't have to hard code that into the logic itself. And that's also obviously useful in things like event condition action rules where you may have an A1C threshold, for example, that determines when the logic fires. CQL Expressions, these are the core content of a given library. So this is, you define, for example, here inpatient encounters as encounters performed, and this name then inpatient encounters is available in other expressions. So a library basically consists of those components. You may use then a library within a larger structure like a measure or an event condition action rule to define, say, the criteria within the populations or the condition logic in the rule. And then the context is another important aspect of a library. So this specifies whether the expression is evaluated with respect to a single patient or with respect to an entire population. And that's something that the evaluation environment provides to the CQL. So when you're writing this, you can indicate that you're writing a patient-focused condition, and then you know that this will only be focused on encounters for a particular patient. Okay, so the types of values you can represent in CQL, we have simple types, just like you'd expect, booleans, true, false, strings, numbers, dates, and times. We also represent clinical types, so quantities and value sets, so you can have 3 months or 6 grams per cubic centimeter. This is a UCOM unit, so you can create quantities of any type, any kind, I should say. We also have structured types. These are the information model. So a patient, an encounter, a procedure, those are structured types. They have attributes that have the values for the information. We also support lists and, importantly, intervals. So you can specify intervals backwards and forwards in time. You can specify intervals of integers. We have effectively full support for the interval type, which is important specifically in measures. So for CQL expressions, the basic things you'd expect to be able to do with an expression language are all available. Standard arithmetic, comparison, logic, and these behave as you'd expect them to. So timing and intervals. Intervals are obviously an important part, being able to understand when something occurred and over what time frame. And in particular, being able to express relationships between events that occurred. So we have the full set of timing operations from QDM. So you can say starts before start and those types of things. You can also say some more sophisticated timing phrases like starts 3 days before the start, starts within 3 days of the start. We also have a full suite of interval operators, and you can access the components, the boundaries, using start of or end of. And then you can test for membership. You can say is a value in a particular interval. So this is the full set. What's important here is just that for any 2 pairs of intervals, you can always characterize the relationship between them. So this is how we know that we have a complete set of operations for dealing with intervals within CQL. So within CQL, we also have support for date-time arithmetic. So I can construct dates. I can convert them from strings. I can do any kinds of manipulations on those values. I can today plus 3 months minus 2 days, for example. And I can calculate the difference in days between 2 dates or determine the duration in some precision of an interval. So those are the types of operations we can perform on date-time arithmetic. So one of the most important things we do, obviously, is get to the data. So in this case, we're dealing with the encounter performed. This is the CQL Retrieve. So all data access in CQL is performed with this operation. It's indicated syntactically with the square brackets. So you say inpatient encounters is encounter performed. And assuming the patient context, this expression will return all the encounters performed for this patient. We typically restrict that to a value set with the colon. This is reminiscent of QDM element syntax here. That's why we chose that direction. But this effectively says encounter performed where the code matches the inpatient value set. That code is implied, just like it is in QDM, where you imply what attribute that is limiting to. But we can also explicitly specify the attribute. So this lets you use a different code if you wanted to, a different attribute of the encounter performed to restrict that value to that value set. So you could say class in inpatient or service type in inpatient, whatever makes sense. The CQL query construct, this is used to perform various operations, including filtering, shaping. This is a core construct within CQL. The simplest query involves just a single source. So what you do is you introduce an alias, and that allows that source to be referenced anywhere within that query. It's a clause-based construct, and there are several different clauses that you can introduce. The first one that we'll talk about is filtering. So a where clause returns only those elements that satisfy the condition. So this one says encounter performed inpatient where the length of stay of that encounter is less than or equal to 120 days. So this will filter only to the encounters that satisfy that condition. And again, we're using the E here to indicate accessing an attribute of that encounter. Can also include multiple conditions. So we'll add length of stay less than or equal to 120 days and the discharge date time during the measurement period. So this will further restrict that result to only those that satisfy both those conditions. And you can use any combination of logical operators to produce the condition you need. So ands, ors, nots, any combination of comparisons. You can also perform calculations in here. It's whatever you'd need to do. So relationships in CQL queries. So you can have a with and a without clause. The with clause allows you to relate information. So in this case, I'm defining emergency department encounters as encounters performed in the emergency department visit value set. And then I'm relating those to inpatient encounters. So I only want emergency department visit counters if they have an inpatient encounter such that the emergency department, so I've used ED as the alias there, discharge date time is 1 hour or less before the encounter, and that E puts you to this inpatient encounters, the E.admission date time. So in contrast to the way this is done in QDM, where I implicitly define the relationship based on the defined start and stop time for every data element, within CQL you specify how that relationship occurs precisely. So I can choose to use start and stop time, or I can choose to use other attributes by defining the condition that defines the relationship between the two sources. So in this query, what we have is a multi-source query, effectively, where this encounter performed is the primary source, and then this inpatient encounters is a secondary source that's being used to restrict what's returned to only those that also have a matching row in the inpatient encounter. I can also shape the information, so I can structure what I want the result to look like. So in the emergency department encounters, I define measure observation here to be emergency department encounters where I have an admission and a discharge date time, and then I want to return minutes between the facility location arrival and the facility location departure date time. So this query will return that calculation for every encounter. And what I'll get out of that is a list of minutes between for each encounter. So then the population context allows us to talk about an expression that would apply over the entire population as opposed to at the patient level. So in this case, I introduce the population context, and I define measure score to be the median of the measure observation that we just looked at. And so because this is population context, that's going to take the measure observations for each patient in that population and perform the median over all of them. So CQL has functions for all the standard statistical aggregates, average, sum, count, mean, median, mode. All the things you would expect there. What we've basically done is build the measure for CMS 55V1. It's a little simplified, but this is effectively the translation for this measure. So we've got the library definition as the header. We say we're using QDM. We introduce the terminology that we're using throughout, so value set inpatient and emergency department visits. So those are just always referencing VSAC value set definitions, just like HQMF and QDM currently do. Then we define a parameter of measurement period. Lets us define what we want the measurement period to look like by default, and then allows the evaluation to perform this for any given measurement period. You can pass in a week or a month or a quarter or the entire year. And then we declare the patient context. We define inpatient encounters as encounter performed in the inpatient value set. So any encounter that has a length of stay of less than 120 days and a discharge during that measurement period. We then define emergency department encounters as the emergency department visit with the inpatient encounters such that the emergency department discharged 1 hour or less before the inpatient admission. And then we define the measure observation as for each of those emergency department encounters that have admission and discharge dates. We want the minutes between the facility location arrival and departure date times. And then we switch to the population context and define the measure score as the median of that measure observation. So CQL Resources, the HL7 standard clinical quality language specification release is available there at that product ID. There's also a CDS workgroup homepage. This is kept up to date. This is the decision support workgroups project page for this for the CQL specification. We keep that up to date with current efforts. There are coordinates there for the calls that support the development. So if you're interested in participating in any of these work groups and the calls to develop these specifications, there's information there. There's also a GitHub Tools repository. This link will take you to the tooling repository for the clinical quality language. We keep this up to date with the specification, and it contains quite a bit of useful tooling for parsing and validating the CQL. So there's a lot there, and if you're interested in the implementation side, I encourage you to take a look at that. So thank you for your time. Thank you for coming. Really appreciate you spending the afternoon with us.